ADCIS presents Computer Vision for Industrial Control. Let me introduce your presenter, Mr. Jerome Abu-Asi, who holds a degree in Computer and Communication Engineering, as well as his master's in Visual Computing. I am Bernie Lukansky, ADCIS representative for North America, and have enjoyed a long career in sales and support for imaging applications and particle size. We ask that you use the Q&A tool or the chat for your questions, and we'll gladly answer each at the end of Jerome's presentation. And while we're asking, please enjoy our presentation with an eye on how ADCIS could possibly improve your own operations. We are eager to help. ADCIS specializes in software for image processing and analysis for industry, R&D, education, health, and many other fields. We produce the Aphelion software suite. Relatedly, we provide services for design and development of analysis, measurement, quality control, and process controls, process solutions, right from the feasibility study through to supplying and installing the solution, including software and hardware. We include maintenance to guarantee the solution's long-term operation, for example, corrective maintenance, updates, and upgrades or obsolescence monitoring. And we include training for users, prototyping, development, or development assistance. ADCIS offers several software solutions matched to the application type and work environment. The popular Aphelion software suite for Windows includes a toolbox for viewing, processing, analyzing, and interpreting images. ADCIS also offers custom-made solutions to meet a specific need where automation and ergonomics are focal points to reduce both human intervention and human errors. These custom-made solutions are available for deployment to Windows or embedded solutions exemplified by drones and other outdoor devices. We even offer prosumer and consumer web solutions, both Android and iOS, for web and mobile apps. Our Aphelion software offers three basic products for three different uses. First, we have Aphelion Lab for analysis labs to measure manually taken samples, a simpler app where we don't require automation. Even so, the lab package keeps the functionalities for image acquisition, calibration, detection, and editing of objects of interest, the measurements, and the report outputs. Second, we have the Aphelion Dev, which is our flagship software product. It is the best suite for application developers, integrators, and research labs. What's different? Dev includes all of the Aphelion Lab version functionalities, plus a complete library of image processing, analysis, and deep learning functions, plus an interface for quick application prototyping, which you'll see Jerome use in his presentation. That's our introduction, and now we move to the heart of our webinar, a working practical example of counting and control of manufactured parts, from the development of specific image processing steps through to the creation of the application and the testing. Jerome, over to you.
Thank you, Bernie, for your introduction. Before we start and we dig deep into the software part of the image processing, it's also interesting to look a little bit on the hardware part, which is always an important element to be taken into consideration in any computer vision application. As you can see on our setup here, we have our stand with a black background and the lighting. Those two elements are essential to have the pieces better stand out from the background. And we also have the camera. The lighting also allows us to reduce the impact of the ambient light to to have more homogeneous images without interfering the noise from the outside. And the camera we are using here is an ADCIS camera. We can also use an Allied Vision, Teledyne Dalsa, or Luminera, or any camera compatible with Direct Show. All those cameras are cameras compatible with our software Aphelion Dev that is used for image processing and develop applications for quality control. We can also use any Ethernet video stream protocol to detect data as well and our images. So to start off, I'm going to present a little bit Aphelion Dev, which is the software we're going to use to develop our computer vision application and apply our quality control. This is the interface of Aphelion Dev. Just a quick introduction, a quick presentation. On the left, we have the different activities in Aphelion Dev, from acquisition, calibration, object extraction, which is an interesting part to be used in quality control. And also the developer part, we can develop step-by-step our algorithms. On the right side, we have a menu that is variable based on the activity we have chosen. And finally, on the bottom, we have an image gallery or an object set gallery where we can see all the elements, the inputs and the outputs, as well as the table of measurements that we will apply on our images and objects. So to start off any application, I'm gonna start the acquisition to see what kind of image we have using our setup. And I will turn on the light as well. As we can see, the image is oversaturated by the lighting. And to solve this problem, we have different parameters that we can modify using the interface of Aphelion Dev. For example, in this case, when the image is oversaturated, we can reduce the exposure time. For example, if I have this value, I can see that the objects are seen clearly and well separated from the background. So we can assume this is a good value to be chosen. Another thing to be done before we start our development of image processing application, we need to define a resolution, to define a measurement distance, measurement value for our pixels. So I'm going to create a new resolution. I will call it demo. Now we have the green segment, and we have to fix it on a distance that we know its value. For example, going from, I will zoom in for more precision, going from 0 till 10, right here. And I will say, for example, select the unit of millimeters, it's 100 millimeters, and I validate. I have fixed my resolution. Now I can remove the ruler because it's not needed in our application. So now the next step will be to develop our application. We can use the image to prototype. First of all, we test different tools to finally get our application. To show you a small example about how the end result could be, I will first of all remove the objects and capture an image from the background to have more precision in the object detection. If I put back my elements, I will show you a small macro we have developed using Aphelion Dev to detect the objects and classify them between, we have the wire connectors here on our setup, and we have to classify them based on whether they are open or closed. We can see the orange part or the opened one. So if I run my macro, now everything I'm doing is based on keyboard shortcuts that I have configured previously to show you how ergonomic Aphelion can be when working with images. For example, the result right here, you can see the detection have been made. We have detected the objects and classified them based whether they are opened and closed using measurements and the image processing as well. So this is how the end result could be. Now we'll show you how we can do this going step by step. I will go back and first of all delete anything I have generated to go from scratch. I have my acquisition running, it's live, and I will snap an image. I will use this image to prototype my my algorithm of image processing to detect the objects and apply some measurements. And then we can generalize it on a folder on other images as well. It's also nice to prototype on different images, but right now we'll only prototype on a single image. Now, to do our image processing, Aphelion Dev has a big library of and a wide variety of image processing tools and functions we can use. When we can work on images and objects, we have the categories and subcategories such as filtering, frequency domain work applications. We can do measurements. We can do morphology functions as well for an images and object set. And we can also access them using the developer menu, where we have the whole list right here, and we can search the function based on its name in the search bar. For example, threshold. We can see all types of threshold we can apply on our images. So to start off our application, we can see the images, and the objects stand out really well from the black background we have chosen. So the color information right now is not essential to detect the contours of our objects. Maybe it can be used later on to detect the opened and the closed elements, but right now it's not essential. So what we can do is switch to a grayscale image to make our processing faster on later stages and simpler as well. So the function to do that is of type color and utility called intensity, and I choose my input image, and the output image will be a new image. I apply it. I have my new image, which is a grayscale image. Now the next step would be to extract those objects. We can apply a simple threshold going from process, image, segmentation, and threshold. I move the cursor along the slider, and with the preview we can see how the output result could be. I can say, for example, right now it's a good result that we can use, and I will apply my function. Now as an output we have a binary image of value 0 and 1. The black background is value of 0 and the red elements are value of 1. Now we can see some contours are well drawn, some others you have some small openings, and it would be nice, for example, to be able to close them. To do that, there's a function of morphology called the close. As the name says, it closes our openings. If we go to image, morphology, opening and closing, and close, we apply it on image 2. The structuring element of square, I will put the size of 11 pixels. We apply it. We can see that some contours are a bit adjusted. Of course, if you want to do more improvements and more precision on our detection, we'll have to apply more image processing functions. But for now, for the webinar, we're going to stick to this result. It will be enough for us to detect our individual objects. So now, what we have right now is a binary image of value 0 and 1, but we don't have individual objects on which we can do our measurements and the detection. So we need to convert this binary image into an object set. If we go into process, object set, bitmap, and generation, we have to generate an object set from clusters. If I use init connected and apply it, we can see in my gallery a new object set was generated. If I show it on my image, we can see a red contour drawn around the object based on the detection we have made. But we can also see that there are small particles, some noise particles that also have been detected using the threshold, and we need to get rid of. It's quite simple. We can see that those small particles are way smaller than our objects we need to detect. So a simple filtering based on the area of these objects is enough to remove them. So first of all, we need to do the measurements. So we do apply the measurements on the object set. Standard shape measurements. I select the object set, the measurements based on the area, and I apply it. To see the result of our measurements, we can look at the object set. We do a show grid. We can see a column showing the area of the different objects we have right here. And when we select them, we see the row, and you can see the value on which we can do our filtering. So now, if I go to object set, filtering, and filter, I have my object set. I filter the attribute based on the area. I set a minimum value of 100 millimeters squared and a maximum value as high as I want. And I apply it. And now to see the result of our new object set that we have created, we can also use a function to draw it on our image. I go object set, display, and draw. I select my newest object set, and I select a nice color to display. I like the green. When I apply it, we can see a green contour around my objects. If I remove the red contours, we can see that we have quite good detection of our objects on which we can do our measurements. We can do, for example, measurements of circularity, of convexity to differentiate the opened and the closed ones, and to do our classification. But what we have done right here is doing step by step, and one function by one, applied on the image. But we don't have a whole package that we can apply directly on an image or on a set of images. What we'll need is to create a macro that summarizes everything that we need and create one algorithm that we can run by one click. That will be faster if we want to apply it on multiple images. To do that, there are two options. First of all, we can look at the C# history right here. Every function we have used have been translated into lines of C# code that we can copy paste into any application that uses the Aphelion SDK. And you can also copy paste it in the macro that you want to develop on Aphelion. But a more interesting tool we have in Aphelion Dev is the possibility of recording the macro we want. We don't need to write any line of code. It's automatically generated when we use the function one by one. If we go in the developer mode right here, we have this C# recording. I will start it. And now what I have to do is do all the steps. After testing all the steps I have done, and I'm being sure that the steps are correct and give us good results, I have to do them one last time in order to record them in my macro. We have a small history we can use to go back to all the functions that we have used. So I need to do them again. I start with intensity by generating a new image. Then we have the threshold. It's the latest image. I will also generate a new one. Then we have the closing function, image 5 on itself. We don't need to have all the intermediate images. Just need one, and we can override it every time to only need the final result of the object set. So I will apply it. Then we have the clustering, the image 5 into a new object set. And then standard shape measurement and the latest object set for the area. And then filtering the object set on itself as well. We override it and we apply it. And finally, we use the draw function. It's object set 3, and I will change the color just to differentiate the two steps. And I apply it. And I can stop the recording. As we can see right here, the code has been automatically generated, and we can use it directly and apply it on the image. To show you an example, I will delete the object sets and the images as well, of course, by keeping my first image. And if I run it right now, I have to save it, of course. Set webinar demo. We can see that it has done all the steps we have recorded. We have our contour. A more interesting thing to do using Aphelion is to save this macro on a list of favorite macros, so we can directly use it based on when using the top bar for the menu. If I select it, I open it, it has been added to my favorite macros. And to have a more ergonomic and faster use of this macro, we can also add a keyboard shortcut. So by simple button click, we run the macro like I have done in the beginning. So if I go to the options and shortcuts, I look for my macro, which is called the webinar demo. For example, I say Ctrl-0 will run my macro. I say OK. Now I will delete my object set. And if I press just Ctrl-0, the contour have been automatically drawn on my image. So what we have done here is we recorded a macro that is applied and allow us to have the detection of our objects. Of course, we can always go further in our detection and our analysis and our measurements. The options are really infinite. But what we'll need right now is another step is like we have applied it on a single image right now. The next step would be to apply it on a folder containing multiple images in an offline detection. But we can also do an online detection when we have a live stream going running and we do the detection live on the stream. To show you an example, I'll show you again the example I have shown in the beginning and another application that we can also apply using those methods. So I will run again the live acquisition. Again, I will remove the parts to capture the background. I will put again my elements right here. And if I run the macro again, we can see detection and the classification. We can keep on doing this. The live acquisition is still going on. We can run it again when moving my objects. Another application that we can show you, here we have a bunch of wall plugs of different sizes. And what we'll need to do is do a classification of those wall plugs based on their size. We have 6, 8, and 10 millimeters. And if I run my macro, you can see the detection of the wall plugs and the classification based on their size. Here, there have been some small error of detection. An object has not been detected. Of course, there is always a place for improvements for our algorithm. Here we still have some basic algorithms, but the more complex the application is, the more development we need to do, but it's always something doable and using Aphelion Dev. So right here we have 2 of 6 millimeters. We have 4 of 8 millimeters and 1 of 10. Okay, 1 of 6 millimeter has not been detected. It happens. So all of this are examples that we can use using Aphelion Dev. We can detect our objects. But right here we are putting our objects manually under the camera and doing our acquisition. This method is doable, for example, in labs when we have some detection of inspection of pieces in lab when we put them manually one by one. But another interesting application will be to use those algorithms on a conveyor, for example, when we have a production line, we need to do quality control or process control. And it's also doable. But in this case, we won't need the whole interface of Aphelion Dev when we have images and buttons. We just need a display of the end result of the measurements we are doing. For example, if we have opened or closed, if we have some good or bad parts. This is all we need to do. We need to have. So the whole interface is not really needed. To do that, we can use the Aphelion SDK, which is a GUI-less use of the Aphelion Dev functions. To show you an example of how we can do that, it's also a very simple application. I will use the macro we have developed during the webinar. I will just copy it, and I will paste it in an application using the Aphelion SDK. I make sure I have Control V. And I will close Aphelion Dev so that the camera can be liberated and used by the other application. I will close that. Now I will share my Visual Studio application. It's a very simple program. I'll just paste my code first. So right here we have the first part, which consists of library management, where all the libraries of Aphelion developed by ADCIS are managed. The second part will be the camera management, where all the calibration and modification we have done in the beginning on Aphelion Dev have to be done here in SDK. And the rest part and the remaining of our code at this part, we have the snap of the image. We define the resolution, and then we do the image processing. And the output in our case will be a counting of the objects we have on our setup. Of course, some modifications need to be done before we run it and it works, because on Aphelion Dev, like I said, we have the interface. In this case, we don't have interface, so some functions can work differently. For example, the draw function is useless in this case because we don't need to display anything, so we can remove it. Another thing to do, the input image is the image we have snapped, so it's image. I need to replace it, it's called image. And in this case, all the functions that start with AS are functions specific for the display on Aphelion Dev interface, where we display the image and we give it a name. In this case, it's not needed. You just need to do a simple image class. So if I say new image, new ADCIS dot images dot image, do it like this for here and there. And for the object set, it's the same thing. So I say new object set. That's all we need to do. So if I run my application now, just a few seconds for it to detect the camera. Make sure it's connected. Now we detected the camera. It's called peak, and it says space bar to start. I will press my space bar, and it will say 7 objects have been detected. And the application I have developed was for the wire connectors and not the wall plugs. This is why it's a bit different. If I put my objects on the board and I press space again, it says 8 objects. And if I count from here, we actually have 8 objects. I will remove 3 of them, for example, and we have 5 objects, and so on. So there is the option to do it using Aphelion Dev interface, or we can do it on a simple console app that runs in the background and give us only the output results. It can be modified whatever we want it to be done. So just to summarize a little bit the different steps we went through. First of all, we need to do the calibration of the camera. When we have good images, we have good results. And then we capture the image. We can prototype on a single image. And of course, it's better to prototype on multiple images to have better results. Then we can use to create our, after prototyping, create our complete algorithm that we save in the shape of a macro. And we can use it whether it's on Aphelion Dev interface, on a live processing, or on a folder of images, or we can use it in a separate console app using the Aphelion SDK to do our quality control on the run. So I will switch back. I will give the floor back to my colleague Bernie to continue the presentation.
Jerome, thank you for this wealth of information. And to summarize, we've presented one straightforward application for control or monitoring production, one that might be used by our many customers for different types of quality and process controls. We again invite you to imagine and reflect on how to apply these flexible capabilities to boost your own production, quality, or safety needs. And we reiterate that we're offering complete software and hardware solution designs that can include integration with the camera, lighting control by the camera, PLC interfaces, and the possibility of triggering the camera with other triggers. Contact us to explore a specific application need or proof of concept work that we can provide using Aphelion and possibly our design and development services. We want to thank you for your time and questions today, and let's turn to those questions now. Back to you, Jerome.
Thank you. If you have questions, like we said in the beginning, you can post us in the Q&A, post them in the Q&A or in the chat if this option is not working on your side. Deep learning methods, yes, of course, we can use the deep learning methods using the Aphelion Dev interface. We can work on them used on Aphelion Dev. Of course, the training part will be outside of Aphelion Dev, but we can apply the neural networks inside the Aphelion Dev interface, and we have functions prepared for that. How do computer vision solutions handle real-time use cases? To use computer vision, like we have presented, we have used only one or two cases, but the options are really infinite. We don't need, those are two out of millions and millions of possibilities we can do, whether the elements are static or are moving. For example, we have a conveyor, and each case will have to be studied by itself. Of course, to have a good detection using image processing, you need to have good images. To do that, like I said in the beginning, the hardware part is always an important element to be taken into consideration, whether it's the lighting that can change from angles, different type of lighting, and the background, and of course the camera resolution and the field of view, and other parameters. At ADCIS, we have the experience with different types of lighting, and different type of applications, and different type of cameras. So we can propose a service of helping based on the application to see what camera to be used, what lighting to be used. And we have our experience, and we have our contacts that can help in any computer vision application. Nothing is impossible.